Hello, ladies and gentlemen. So today we're going to look at inverse functions, which you're going to want to have on you, the notes I gave you, and then a pen or a pencil. So the definition for inverses. Technically, what an inverse does is it interchanges the x and y values of a set of points, equation, etc. So basically what happens is the x's become the y's and the y's become the x's. So that's an idea that we're going to want to keep in our minds as we look today. Here's the basic idea, and you don't need to write any of this down. Just kind of watch this. So here's this original set of arrows. So I have 4, -8, 4, -8. If you notice, as I plot my points here, these actually are going to make this arrow here. 4, -5, 3, -5, 5, -3, that's the point of my arrow right there. 7, -5, it's about right there. 6, -5, and 6, -7, right? Oop, that should be 6, -8. Should be a -8 right there. There we go. Let's fix that. -8. Alright, so now what we're going to do is we're actually going to, for the inverse, take the y values right here and make it our x's. So my x values, I have -8, -5, -5, -3, -5, -5, and -8. Notice how my y's became my x's over there. Now let's check our x's. Let's make those our y's. So I have a 4, a 4, a 3, a 5, a 7, a 6, and a 6. So my x's became my y's. So now let's plot these new points. -8, 4, -5, 4, -5, 3, -3, 5. It's the point of my arrow right there. -5, 7, -5, 6. And -8, 6. So if I draw in my arrow here, look how my arrow turned. Now, what this is doing is it's technically reflecting you across y equals x, which is right there down the middle. So it's taking this arrow and reflecting it across that line. So it's going to look a little sideways. So how are we going to use this? What we're going to do is we're actually going to graph functions and its inverse. So on this one, let's first fill out our first table. I can use any numbers, so I'm going to do -2, -1, 0, 1, and 2. Plug in some values here. So -2, let's just put it off to the side here. -2 cubed plus 4. I know that's -8. +8, that should be a +12 there. If I make this a -1 there, I'll get a -1, +1, 5. You can just be putting this into your calculator. That's the easiest way to do it. 0 is going to give me 4. I'm going to get 3 here, and a -4 there, it looks like. So now, let's graph these points. Can't graph -2, 12, but I can graph -1, 5. Whoa, that was a really bad point. 0, 4, 1, 3, and 2, -4, right there. So it's going to look something like, go through those points, and then go like that. Something like that, right? So now, our inverse, we're going to graph the inverse, and I'm going to do a different color here, just so I don't get lost. So I'm going to write my new points. I have a point of 12, -2. This is my x, and this is my y. 5, -1. Notice how I'm just flip-flopping my x and y around. 4, 0, 3, 1, and -4, 2. So now let's graph those points. Let's see what this looks like. 12, -2, I can't graph that. But I can graph 5, -1, and I can graph 4, 0, and I can graph 3, 1, and I can graph -4, +2. My graph looks something like that. Notice how it's basically the same graph, but just turned on its side. So it's been turned. Now, to answer the question, is the inverse a function? How to tell that? Vertical line test, pencil test. So you're going to be able to take, let's see, if I draw any line down this blue line, we're looking at the blue, remember. Do we have a function? Do I ever hit that line more than once? No. So, yes, it is a function. I do not hit it more than once. It passes the vertical line test. Let's try this one. So we need to graph this function and its inverse. So let's first graph the function. So I'm going to use the same points, -2, -1, 0, 1, and 2. Plug in that -2. So up here, I'm just kind of going to write what I'm going to be doing here. -2 squared, that is 4. 4 times -2, that's -8. Plus 1, that's -7, I think. -1, so if I cross out -2, put a -1 there. -1 squared, 1 times -2, -2 plus 1, -1. Plug in over 0, I hope I get 1. 1 squared, 1, -2, -2, -1. Oh, look. It looks like it's a pattern. 2 squared, 4, -8, -7, because it's a squared. Remember, there's always mirror on those. Let's go ahead and graph this. -2, -7. Whoops. -1, -1. 1, 0. Or 0, 1, excuse me. 1, -1. And 2, -7. Graph that. Whoa, that's a very wobbly parabola. Yours is going to be a lot better than mine. I know that for a fact. Let's go dark blue this time. So now I need to do my inverse version. So, flip-flop my x and y's. -7, -2, -1, -1. It's like I didn't even flip it. 1, 0, -1, 1, -7, 2. Let's graph these. -7, -2 right there. -1, -1. Hey, I went through the same point. 1, 0, -1, 1, and -7, 2. Let's cut through. Something like that. Alright, now, is the inverse dark blue? Is that the function? Is it a function? Remember, vertical line test is the easier way. Another way, look at your x's. Do you have any double x's anywhere? Well, gosh darn it, we do. We have a bunch of double x's. This guy is a no-go. If you look here, the vertical line right here, I hit once and twice. I hit twice. That means I don't have a inverse, or I don't have a function there. But we don't want to graph every time. That's going to take forever, and it's going to be really boring. So what we're going to do, when we are given a function, what you're going to do is exchange x and y. So my y and my x are currently there. What I'm going to do is I'm going to flip-flop. So my y became my x, and my x became my y. Now, you're going to now solve for y. So I'm going to subtract 5. X minus 5 equals 3y. Divide by 3. I have now solved for y. That means I have found the inverse of my function. Now, let's try number 2. I need to exchange x and y first. That's my very first step. Now, I need to solve for y. what I would do right now, this is division by 3. Let's get rid of that division. Let's multiply by 3. So we would have 3x equals 3 and 3 cancel. I'm going to get 4y minus 5. Let's add 5 to both sides. 3x plus 5 equals 4y. We're not done yet, though. Y is not solved for. So let's divide by that 4. Done with that one. Y is solved for. He's as simple as he needs to be. I am done with that problem. Let's go for some little harder buddies here. So we have exercise 3. Y equals 3x cubed plus 5. So let's exchange x and y. Very first step. Start solving for some y. So let's get that y cubed alone. So let's subtract 5 here. X minus 5 equals 3y cubed. Let's divide by 3. X minus 5 divided by 3 equals y cubed. How can I get rid of a y cubed? Cube root. So let's cube root both sides. So my answer, even though it looks gross, the cube root of the quantity x minus 5 divided by 3 equals y. Looks gross, I know, but that is the inverse function of this particular problem. Let's try exercise 4, shall we? So let's flip-flop our x and our y. Start solving for y squared. So let's subtract that 1. X minus 1 equals 2y squared. Y squared's not alone. Let's divide by 2. Oh, I think we've seen this before. How do you get rid of a y squared? How do I make that just a y? Racking my brain here. Oh, I think we need to do a square root. I think I remember that. Now, remember, whenever you do a square root, you get a plus or minus. Don't forget about that. X minus 1 divided by 2 equals y. That's only when you do a square root, though, not a cube root. So, summary. These are what you're going to want to have in your notes so you actually know what to do. How to find an inverse. Switch the x and y and solve it for y. That's when you're not given a graph. How to graph an inverse. Switch the x and y in each point of the original and then graph. You will get the inverse that way. Is it a function? How to decide. If it is a function, it will pass the vertical line test, aka x's aren't repeating. And that is inverses. See you later.